Atkins Civil 3D video series, STRM 3E, STRM channel enhancements. This video illustrates A. Create existing and construct channel profiles, B. Add channel enhancements in plan, and C. Add channel enhancements in profile. The preparation of construction drawings for STRM channel improvements generally consist of the creation of alignments, profiles, assemblies, corridors, cross-sections, etc. in a similar fashion as used in the creation of road improvements. These type of channel improvements are not included in this video series. At times, when the improvements for STRM channels are relatively minor and are associated with other improvements, drawing enhancements are shown in plan and profile on the current set of drawings to illustrate the channel improvements. Standard AutoCAD procedures are used for the majority of the work shown in this video. Civil 3D was only used in the creation of the existing ground profiles. STRM channel improvements are required at 3 locations for the Kincaid Road Improvement Project. The pipe network alignments and profile views have been extended at these locations to show the existing surface profiles for the channel improvements. At 17+10, concrete slope paving needs to be constructed at the head wall, and an earthen channel needs to be graded for approximately 50 feet to join the existing channel. At 26+53, concrete slope paving needs to be constructed at the head wall, and the existing concrete channel needs to be reconstructed for approximately 250 feet. At 36+30, concrete slope paving needs to be constructed at the flared-in section, and the existing concrete channel needs to be reconstructed for approximately 20 feet. At times, it is desired to show the profile of the existing ground surface at an offset distance from the alignment after the profile view has been created. Such is the case for the pipe network at 26+53, where the existing ground profile is desired along the top of bank of the existing channel, which is approximately 10 feet west of the alignment. Pick the pipe network alignment. In the context-sensitive ribbon, Launch Pad Panel, Surface Profile icon. Select Surfaces, select the existing surface with aerial. Sample Offset, enter -10. Add. Change the style. Select Existing Ground. OK. Do not draw and profile. The profile view has already been created. OK. In the Events panorama, Action, Clear All Events, and Close Panorama. The top of bank offset profile is shown. Where the location of the desired profile of the ground surface is not at a uniform offset distance, a quick profile and superimposed profile need to be created. Such is the case for the pipe network at 17+10. 2 polylines have been drawn in plan view, one for the existing channel flow line and the other for the existing west top of bank. Create a quick profile of the flow line polyline. Home ribbon, create design panel, profile, quick profile. Select the flow line polyline. Remove check mark and select all profiles. Select the existing surface with aerial, profile style, existing ground, OK. Profile view style, 20 horizontal, 5 vertical center line, no labels, OK. Pick a clear area, approximately 300 feet of the profile grid sheet. The Events panorama is displayed, which indicates that the quick profile view is temporary object and will be deleted on the Save command. Clear Events and Close Panorama. Create a superimposed profile. Profile, create superimposed profile. Pick the quick profile. Pick the profile view. On the limits, place check mark in the select start and the select end, leaving the stations unchanged. OK. The superimposed profile is shown. X, enter. To start the explode command, pick the superimposed profile, enter. The profile is changed to a block reference, which will not be deleted when the drawing is saved. Save the drawing. The quick profile has been deleted, but the block reference remains. Repeat for the West Top of Bank profile. Where a drainage channel discharges into an RC box or pipe, concrete head wall and wing walls are constructed to funnel the stormwater flows to minimize turbulence and head losses. The head wall and wing walls for the RC box at 17+06 are drawn in profile view. The head wall is 12 inches thick and is constructed on the top of the RC box. The top of the head wall is 2 feet above the soffit of the RC box. The RC box and head wall are located so that the back of the head wall intersects the finished grade approximately 6 inches below the top of the head wall. The wing wall is 9 inches thick and extends outward, with the inside face of the wing wall being an extension of the inside wall of the RC box. The top of the wing wall at the head wall is at finished grade and slopes downward at 2:1. To minimize the volume of concrete in the wing walls and slope paving, the wing wall footings and floor slope upward at approximately 5:1 until they intersect the sloping top of the wing wall. The dimensions and elevation of the wing walls are adjusted to an even foot that do not exceed the 2:1 and 5:1 slope parameter. The head wall and wing wall footing and face are hatched in the drawing. Enter. The ANSI 131 hatch pattern is presently selected. It has an angle of 0 degrees and a scale of 10.0. Pick the footing in the head wall. Escape. Hatch the face of the wing wall. Enter. Select the Atkins concrete hatch pattern. Angle, use 15 degrees. Scale, use 5, and pick the polyline. Escape. During construction, steel dowels are installed to connect the head wall and wing walls to the RC box. 6-inch thick concrete slope paving is constructed along the bottom and side slopes of a channel to prevent erosion. The slope paving associated with the wing wall and head wall is drawn in profile view. The bottom of the slope paving has the same width as the RC box and extends upward from the floor of the wing wall at a maximum 2:1 slope until it intersects the channel grade. The horizontal length of the slope paving is adjusted to an even foot that does not exceed the maximum 2:1 slope parameter. At the front of the slope paving, the concrete extends up the channel side slope at 3:1 to a height that is 2 feet above the channel bottom. A concrete cutoff wall is constructed along the bottom and sides at the front edge of the slope paving to prevent undercutting. The side slope varies from 3:1 at the front of the slope paving to 2:1 at the front of the wing wall, with the top elevation being parallel with the upstream channel grade. The slope paving continues at 2:1 along the wing wall to the front face of the head wall. The bottom and side face of the slope paving are hatched to match the wing wall hatching. Enter to start the hatch command. Pick the slope paving bottom. Escape. Hatch to restart the command. Pick the slope paving face. Enter. Enter to start the match command. Pick the wing wall foundation hatching. OK. The profile and plan views are used to determine the limits of the concrete slope paving and the limits of the surrounding 3:1 earth and slopes. The head wall, wing walls, and concrete slope paving are drawn in plan view. At this location, the side slope of the concrete paving is 3:1 and the height above the channel bottom is 2 feet. The top of slope will be at a horizontal distance of 6 feet from the bottom. At this location, the side slope of the concrete paving is 2:1 and the height above the channel bottom is 4 feet. The top of slope will be at a horizontal distance of 8 feet from the bottom. In this section, the top of the slope paving is a straight line to where it joins the head wall. The height of the finished surface of the surrounding area varies between 2 to 2.5 feet above the slope paving. At a 3-to-1 slope, the horizontal distance of the surrounding earthen top of slope will vary from 6 to 7.5 feet from the edge of the concrete slope paving. A handrail will be installed along the top of the head wall and wing walls. Since riding lawnmowers can be operated on 3-to-1 slopes, earthen slopes should be 3-to-1 or flatter where possible. An earthen channel with 6-foot bottom width and 3-to-1 side slopes is to be graded upstream of the concrete slope paving for approximately 25 feet, and the grading is to continue upstream with variable width bottom and variable side slopes to join the existing channel. The limits of the channel grading has been drawn in plan and in profile. The earthen channel bottom and side slopes are to be lined with Bermuda grass sod. Poly lines on layer C road-hatch line have been drawn around the limits of the sod in plan and in profile, which needs to be hatched on the drawing. H. Enter to start the hatch command. Pick the poly line in plan view. Pick the poly line that's drawn around the head wall and slope paving. Poly line. Escape. The hatching shown needs to be modified. Pick the hatching. In the context-sensitive ribbon, scroll up. It's the grass hatching. Scale 2. Leave the angle at 10. Enter. Escape. Use Properties palette to change layer to Sea Surf Ground. Pick the hatch. Pick the current layer. Pick Sea Surf Existing Ground. Escape. H. Enter to restart the hatch command. Select the polyline in profile. Enter. M. A to start match properties command. Pick the hatch in the plan. Pick the hatch in the profile. Escape. Freeze layer C road hatch line. A polyline is shown around the top of slope in plan and in profile view. Pick the top of slope line and use Properties palette to modify the line type style. Pick the current style. Scroll down to slope. Move cursor over slope left and slope right and notice the change in the drawing. That's slope right. This is slope left. Select slope left. Change the line type scale to 0.75 and notice the change in the drawing. Escape. Use match properties to change the line types for the channel flow line in plan view. M. A. Enter. Select the top of slope line. Zoom in and pick channel flow lines. Pick the slope line and use Properties palette and select slope right. M. A. Enter. Pick the line type style in profile. Select the top of slope line, polyline. Escape. This video is a part of the Civil 3D video series created by Gerald Atkins of Atkins Engineering. Visit www.atkengr.com for instruction manuals, tutorial drawings, template drawings, and Civil 3D videos.